So today I want to talk about some basic things to do with programming in Python, and actually programming in most other programming languages. It's mostly arithmetic that we're going to talk about, but even if you think you know this stuff, I can guarantee, or not guarantee, but I'm sure you won't know everything about everything that we're going to talk about today. So here I am at the command line, and I'm going to start Python. There we go. This is the Python interpreter. This is where you can fool around in Python to learn what different things do. You can just type Python code in directly, and it immediately executes it. And when you run Python, you'll see something like this. Might be a little bit different because you won't be using Linux necessarily. You may be using Windows or Mac OS, but that's fine. So let's type something in. 2 * 4. Type that in, and it tells me 16. Anybody know what that does? Yeah. Yeah. So * is the notation for exponentiation. So that's 2 to the power 4, or 2 times 2 times 2 times 2, 4 times. So that's where that comes from. You can work with fairly big numbers in Python, fairly big integers. So that's 2 to the 32. That's 4-point-something billion. But 2 to the 320 is fine also. That's a huge number. If you've worked with other programming languages before, like C or Java, this should already be somewhat surprising to you. Most languages won't let you work with an integer that's this big. But Python handles that for free. So you can use Python like a calculator, and it has all of the usual arithmetic operations. So for example, 4 * 5, what's that going to give me? 20. So star has at some point in the last 30 years become the notation for multiplication almost universally. How about if I say 4 / 5? What's that going to give me? Division. So slash is division. This is 4 divided by 5. Anybody tell me what the answer is? Yeah. So 0 is one answer. 1 is one answer. 0.8 is another answer. So mathematically, what's correct?
Yeah, I'd say 0.8 because Python doesn't round.
0.8. So 0.8 is the winner. So the answers 0 and 1 were from people who have some programming experience. 0 because what comes before the decimal point is 0, and in many languages, that's all you get when you do that kind of division. And 1, I guess, because 0.8 is closer to 1 than 0. So if it was rounding to an integer, 1 would be the natural choice. That's what other programming languages do. That's sort of what Python does, is it just does the division and gives you the correct answer. Sort of, I'll come back to that shortly. You have to tell Python that that's what you want it to do. There is the other interpretation also is possible. And of course, the usual stuff. You can add numbers. You can subtract numbers. All the usual things. And all right, how about if I say something like this? 8 minus 2 minus 2. What's that going to give me? 4. Okay. How about if I do this? 8. Okay. So this actually tells us something about the way Python interprets these formulas. It tells us that at least if all I'm doing is one kind of operation, in this case subtraction, it interprets the formula from left to right. So it takes 8 minus 2. So in the first case up here, it takes 8 minus 2, giving me 6. And then it subtracts 2 again from that, giving me 4. If it interpreted from right to left, well, it would have done the 2 minus 2 first, giving me 0, and then subtracting that from 8, which would be 0. So Python evaluates things from left to right, except for what? Yep.
Brackets?
Except for brackets. Anything else? Yep.
Does it follow proper bedness, or?
It follows proper bedmas, which is brackets, exponentiation, division, multiplication, addition, subtraction. And it's not strict in that order. Brackets is the highest priority thing, so that's why 2 minus 2 got done first in the second case. Exponentiation is the second highest priority. Division and multiplication are at the same level. So they'll just get evaluated left to right, and addition and subtraction are at the same level. They'll get evaluated left to right. Okay. Anybody see what I just did there? I wrote something that nothing happened. Yeah. So in Python, if you want to write a comment that is just for humans to read, somebody who's maybe later trying to understand your code, you can prefix it with this thing. It's called the hash symbol or the octothorpe or the pound symbol. And that tells Python that whatever is left of this line, it should not bother reading. This is here for a person to read, not for Python to bother trying to interpret. Okay. So let's try and compute maybe something useful, something slightly useful. So one thing computers get used for a lot is numeric calculations. And so something I'm pretty sure all of you have seen is if I have a circle whose radius is r, then what's the area of that circle? Yep. Pi times r squared. So that looks like one of these formulas that we can evaluate nicely in Python, right? It has exponentiation, the squaring, it has multiplication. Fantastic. So let's say I'll take this circle to have radius r is equal to 4. Now I want to know what's the area of a circle whose radius is 4. So I want to evaluate the formula pi times 4 squared. So what's pi? So pi is 3.14 times r. R in our case is 4. And it's actually r squared that we want. Now let's check. Order of operations says the exponentiation will get done first before the multiplication, and that's exactly what we want. We want to square the value 4 before we multiply it by 3.14 by pi. Okay, and so that's the area of a circle whose radius is 4. If I want a circle whose radius is 3, I just have to change the formula. If I want the area of a circle whose radius is 1, that's a good check because that's one we can know the answer to. It tells us the answer is 3.14 or pi. Anything wrong with this code? Anything wrong with this calculation? Yeah. Yeah. Our definition of pi is pretty weak, right? It's only good to 2 decimal places, and if you know anything about let's say the theory of pi and irrational numbers, you'll know that actually pi has an infinite number of decimal places, and we've calculated pi out to billions of decimal places. So we might like to say use something a little bit better. So let's find a better definition of pi. So here's a definition with 100,000 digits. That looks good. Let's stick with the first 80 or so and use that. Okay, so there's the area of a circle whose radius is 1. We actually got back less than we put in here. That's something you'll learn about, is that there's rounding errors, but we get a better result. So for example, if we go back to our original, what's the area of a circle of radius 4, we get a lot more digits, a lot more precision in our answer this way. Now I'm able to do this quickly because one of the features, at least of Python on this terminal, is the scroll back feature. When I press the up arrow, I get the previous line that I typed in. If I press it again, I get the line before that, and so on. But you can see how if you were writing a program, let's say in a text editor, this would get tedious. In particular, if you're using whatever we're using here, it looks like 80 digits or so of pi, that would get tiresome trying to type that in. So what you can do instead is define a variable called pi. There. So what we just did is we said, here's this thing, we'll call it pi, pi, and we're setting it equal to this number 3.14159, so on. And now, if we want to do these calculations, two things happen. We get to use that variable, so we get to just use this number pi, and in the calculation it gets substituted with this decimal expansion that we gave it. So that's one thing. It saves us from having to type pi in all the time. Yep.
So does Python automatically declare it to be an integer or a string depending on how you define it? Or?
Yes. So one of the nice things about Python, and one of the things which makes it such a fantastic language to learn to program in, is there are no types of variables. So if you want to define a variable, the way you define it is you assign something to it. You don't have to say that this variable is of a specific type. You just assign something to it, and now it's that type, and that type can change. So you may not know what this is yet. We'll see that soon. But there. Now I've just redefined pi as a big slice of pie, and that's, if you know a little bit about programming, that's a string now. Before it was a number, and there's no problem redefining a variable to have a different type in Python. But let's go back to this numerical definition. So two good things happened here. One is we stopped having to type in all of these digits of pi. The other is this formula now is actually a lot more understandable. If you saw this, you could read this as pi times 4 squared, which then, if you know a little bit of geometry, you'll realize, oh, this is the area of a circle of radius 4. Whereas before, it takes some effort to parse that other thing, in particular because just the digits span 2 lines already. So, so defining variables for these kinds of things that you're going to use over and over, that's a good thing. Okay. So let's go a step further and say, well, computing the area is nice. It's maybe something that in our work we're going to have to do a lot, and so we would like a quick way to do it, or a way that's easy to understand. In particular, we would like a way that's not error prone. So for example, if I'm writing a lot of code that's computing a lot of these things, at some point I'm going to make this mistake. I'm going to mistype, and I'm only going to multiply by 2 instead of raising to the power 2. And look, I got an answer. There's no warning. Nothing told me there's an error there. That mistake will go undetected. for, well, until it causes a problem somewhere else. And so, well, if we have these sorts of formulas that we're going to reuse over and over again, one useful thing to do with them is to save them. And so here we go. We've been writing a formula for the area of a circle. So let's, rather than always have to write this formula, let's just define the area of a circle. And, well, what's the radius of the circle? Well, we'll call that radius r, just like you see in most math textbooks. So we're now defining the area of a circle. And what's the area of a circle? Well, anybody? Yeah. Pi times r squared. Beautiful. It looks just like the formula you see in a math textbook, except that we're lacking some typesetting here. We can't write the 2 as a superscript of r, but this really looks, I mean, from this you can really see that this is the right formula for this thing. Great. Now we've defined the area of a circle. How do we compute the area of a circle now? Yep. Call the function. All right. So what we've just done is define this thing. It's called a function. Def stands for define. And this colon here at the end says, okay, actually what's coming up is the definition of something, or there's some other stuff coming up that's different, that's part of this. And actually when we put that colon there, that's why the interpreter gave us this ... It's telling us, okay, I'm still waiting for you to finish defining this thing. And it wasn't until we did that, and then we actually had to hit enter twice for it to stop waiting for us to define it. But once we've defined it, we can actually use it. There we go. So this asks us for this is the way we compute the area of a circle whose radius is 4, area of a circle whose radius is 1, area of a circle whose radius is 2 to the 32. So it works for all of these things. Anybody see anything weird with that last one? Yeah. Yeah. So once the numbers get really big and they're not integers, they start getting expressed in scientific notation. So this is 5.7952 and so on times 10 to the power 19. But this is just the shorthand for that, the scientific notation. Or if you like, it's 5, 7, 9, blah, 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 all these digits, and then a bunch of zeros so that the number of these digits is 19. So move the decimal place 19 digits to the right. Okay. Let's do another one that illustrates something else. So there's a rectangle. Rectangles have, well, these kinds of rectangles, or at least for what we're interested in, they have two things. They have a width and they have a height. And what's the area of a rectangle? It's the width times the height. So let's quickly define a function that computes areas of rectangles. Okay, so in our area of circle example, we had one argument to the function. It was called r. What's going to happen here? Yep. We need two arguments, w, the width, and h, the height. And when we want to have more than one argument, we just do it the same way as one argument, but we put commas separating the names of these things. And we return w times h. And so let's check to see if that works. Rectangle of width 2 and height 6 has what area? 12. Good. Seems to work. Fantastic. All right, so this is great so far. We've worked a few examples through. We know about order of operations. We know about the different kinds of arithmetic operations. We know that we can define variables, and we know now that we can even define functions, so things that are computed on arguments. But it's going to very quickly work out that, you know, working from the command line like this is becomes tiresome, cumbersome. It's not what we want to do forever. Sometimes, in particular, if I leave Python and then come back, so I just quit. That's the way you. One way to quit Python is just to call the quit function. When we come back, let's say I want to look at pi again. Oops, pi is not defined. It was only defined in the previous run. Area of rectangle. Yeah. Area of rectangle. That's not defined either. All those things are forgotten. So we've lost all our work in some sense. So we don't want to do that. In fact, we want to save something from today's work. So let's save it in a directory called September 10th. And let's work in a file called day1.py. So Python program files always use the extension .py. That tells a lot of things, the operating system, Python, many other tools, what kind of data it's expecting to see in that file. And we can put our code in there. So the code that we're interested in keeping is the definition of pi. We're interested in keeping the area of the circle. And we're interested in keeping the area of a rectangle. Save that in day1.py. And now I can actually run day1.py. What's going to happen? Yep.
You'll get the worst output error because you don't have any commits.
Yeah. So it runs, and that's it. So it ran, it defined a variable called pi, it defined a function called area of circle and another function called area of rectangle, and that's all the file told it to do. So it defined those things, and then it was over. So what you'd normally do, well, it depends exactly what you want to do, but many times you'll create files that do nothing but define functions because you want to use them somewhere else. One way to use those is interactively, and you do that by passing this argument -i to Python, which says, I want you to run interactively. So yes, open this file, but then go to interactive mode, open and read this file and do whatever it tells you to do, but then go into interactive mode and wait for me to type some commands. And now, indeed, all of those things are defined. So everything is still there. You can use them that way. And I'll go back and deliberately make a typo here. So, okay, so what was the problem there? What just happened? Yeah, so that's a misspelling of circle. Any of us can probably tell what I meant to write there, that this should have been area of circle. The Python interpreter, though, is very specific. It doesn't try and guess what you mean when you make a typo. It just says, look, there's no function called area of circle. So this is an error, and it's telling me about this error. And you need to get used to reading these things. So you will see lots and lots of these errors. They start with traceback that shows you usually a list of different function calls, and then the type of error that occurred. This is a name error. It's saying this name is not defined. There's nothing in the program that has this name. Okay. So a couple of things we've seen now that we've just seen them, but you may not have noticed. So for example, if I do 5 times 4, I get the answer 20. What happens if I do 5.0 times 4? Yep. Yeah. So again, this is a difference between pure mathematics and what happens inside a computer, but there's a clue here that something different is happening, even though mathematically 5.0 is the same thing as 5. But actually, inside a computer, these are two different kinds of numbers. 5 is an integer, and 5.0 is what's called a floating point number. And these things get treated differently. And so it's important sometimes to understand what's happening and which kind of number you're using. And sometimes it's useful to go to translate between them. And well, first, how to translate. So let's say that I didn't want this behavior of getting a floating point number back from this expression. Well, I could say I want to turn whatever this thing is into an int. So that does it. It gives me the value 20. Anybody know what happens if I turn 5.6 into an int? Yep. Nope. So it just does truncation. It just erases whatever is after the decimal point. So even if I try and turn 5.99999 into an int, you can't convince it to round up. It's just going to give you back 5. And I can also go the other way. So 5. If I want, I can turn that into a floating point number like that. Okay, so that takes the integer 5 and converts it to a floating point number. Now a couple of things. Well, here's something we looked at before. 4 divided by 5, we get the answer 0.8. Some of you wanted the answer 0. Or if you like, let's say 12 divided by 5. Some of you would like the answer to that to be 2, but in fact you get 2.4 here. So sometimes you want to do division, but you just want the whole part of this division. Anybody know how you get that in Python? Yeah.
You use //
Yeah. So there's actually 2 ways to do division in Python. One is the exact way using slash, and the other one is just the integer division way, which you use // You call this the div operator, and that does this the way that division works in many other integer division works in many other languages. Yeah.
Is there a reason why when I do 4/5 I still get 0?
Yeah.
I do too.
Yeah. We'll get to that in about 2 seconds. So there you go. If you want this integer division, you can get that. And related to that is this operator called the mod operator. Anybody know what this gives you? It gives you the remainder. So it gives you 2. So maybe let's take 11 mod 5. That's a more illustrative example. So 11 mod 5 gives you 1. 11 div 5 gives you 2. And that's telling you that 11 is 2 times 5 plus 1. So these two things, the div operator and the mod operator, let you write one number, in this case 11, in terms of another number, 5. So 11 is 2 times 5. That's what you get when you do the division. 2 plus 1, that's the remainder. So that's what these two operators together give you. Now, back to your question. Why do you keep getting 0 and I keep getting 0.8? Does anybody see why? Yep. Yes. So old versions of Python did had this behavior that if I take one integer and divide it by another integer, then the result is going to be an integer. And it's just the whole result. And what they very quickly realized is that was a mistake. So for example, let's say I want to do something like area of triangle. So what is the area of a triangle? Yeah. Let's say a triangle that looks like this. It has some length on the base, and it has some height. Well, the area of that triangle is the base times the height divided by 2. So let's write that. We have a function called area of triangle, takes two arguments, base and height, and we say return base times height divided by 2. All right. Anybody see where there could be a problem here? Not yet.
Divide the height first.
That doesn't matter. It'll go left to right. So it'll multiply by 2, but it wouldn't matter even if it divided first. Yeah.
Is there a problem if you use the same variable in those functions?
No, variables, when you use them like this, they only live. The way you say that in programming jargon is it only has scope inside the function. Yeah.
Is it going to be the fact that if, say, height's 3 and you divide it by 2, it's going to be 3.5 or 1.5, and if it's an integer, you don't 0.5?
Yeah. So let's go and test this thing out. Let's say we have a triangle whose base is 2 and whose height is 1. No, let's say a triangle whose base is 1 and whose height is 1. So that should be 1 times 1 divided by 2 should be a half, and that's what we get. Now, if I go back to the old way of doing things, I get 0. And that's clearly not what we wanted, right? And so they very quickly learned that they'd made a mistake in the way they were doing division in Python. And so unfortunately with programming languages, when you make a mistake, people still write code that depends on that mistake. And so you have to keep some way of doing the old method and some way of doing the new method. So in Python, they have to keep the default being this integer division. The way you avoid that, well, there's two ways. One is you pass this argument on the command line, which is -q new. So if you read the documentation for Python, you'll see that this says use the new definition of division. Now, when you're writing something like this, you're writing a program like this or a file like this, you don't want to have to rely on somebody always remembering to pass that argument on the command line. So if I want this to work no matter what happens on the command line, I'll add this to the top of my file. So we'll see that actually this syntax here, from something import something else, is used to to get functions or certain behavior from other files. This is a really special one. It says, I want you to go to the future and import this new meaning of division, the correct meaning of division. So I would like you, certainly for the first assignment and almost every time you write a Python program, this should be one of the first lines in your file. Okay? From future, import division. Otherwise, you're guaranteed to run across one of these kinds of bugs one day and you won't understand what happened. So do that and you'll get the natural definition of division. Yep.
Is it one or two underscores before and after future?
It's 2 underscores. Yeah. So that's telling you that this is really, really special. 1 underscore would mean that it's really special. 2 means it's really, really special. Okay.
Sorry, is there a space in between the from and the?
Yes. This file is already available on the web, by the way. So you don't have to copy down everything that I'm saying. Okay, so let's go back. And let's go back and revisit this division and multiplication or division and modular arithmetic thing. So why would you ever want to do integer division? Why would you choose to do integer division? And why would you want this remainder operation? Anyone give me an example of a kind of arithmetic or a kind of thing you do every day that sort of works like that? So I'll tell you something. I have office hours in 1 hour and 51 minutes. What time do I have office hours at? 1. So it's 11 o'clock now, and I add 1 hour and 50 minutes. It's 11:09 now, and I add 1 hour and 51 minutes, and the answer is 1. So that's a kind of modular arithmetic, right? The real answer was I add 1 hour and 50. Well, now it's 50 minutes, and the answer is 13. But we don't talk about time that way, right? Time is, at least most of us, unless we're in the military, talk about time on a 12-hour clock. So when we do these kinds of additions, we actually we have this kind of thing happen. How about on a most of you have used a microwave before. What happens on a microwave if you press 90 and start? Yeah, so depends on the microwave. Mine's actually kind of weird, so it just counts down from 90. But some of them you'll press 90 and start, and it'll show you 1:30 and start counting down from there. 1 minute and 30 seconds. So 90 seconds is 1 minute and 30 seconds. So it seems that if we give a time in seconds, we can convert it to something that is in minutes and seconds using these things. So as an exercise, let's try and do that. Let's say seconds to minute seconds. So let's say that I have a time that is in seconds. That time is S. And I want to convert it to 2 parts. I want to split it into 2 parts, the number of minutes and the number of seconds. How do I get the number of minutes? Yep. Yep, divided by 60. So number of minutes is the number of seconds divided by 60. Is that right? Integer division. I want this minutes thing to be an integer, right? So that's exactly what I want. Now, how do I get the number of seconds that are left? Yep. Use the mod operator. Okay. All right. So 2 things. So let's test that. Seconds to minutes, seconds, 90. 1 minute, 30 seconds. Seconds to minutes, seconds, 59. 0 minutes, 59 seconds. Minutes to seconds, I don't know, let's say 3,600. 60 minutes. There's 3,600 seconds in an hour. So it seems to work, right? So 3,612, 60 minutes, 12 seconds. Anything weird happening here? There should be something new to many of you. We're doing something here that doesn't show up in most programming languages. Yeah.
You're able to return two different values from one function?
Yeah. So what we just did there is we wrote a function that wanted to convert from seconds to minutes and seconds, and we rewrote it so that it actually returns both values. In many other languages, you would have to write two functions to do that. One that gives you the hours or the minutes, one that gives you the seconds. In Python, you can actually return more than one argument or more than one value. Technically, what you're returning is a thing called a tuple. In this case, it's a tuple of length 2. It's a pair with 2 parts. So let's extend this a little bit. What if we want to convert to hours, minutes, and seconds? So I have a number of seconds, and I would like to express that in hours, minutes, and seconds. How do I get the number of hours? 360? 3,600, yeah. So to get the number of hours, I take the number of seconds, and I divide it by 3,600. How do I get the number of minutes? Yeah? All right, let's try that. Seconds divided by 60. And the number of seconds is seconds mod 60. Is that going to work? Why? Why not? Yeah.
Because we're not using the remainder, we're using the whole thing.
Yeah. So, oops. So this says in 3,612 seconds, there's 1 hour, 60 minutes, and 12 seconds. That middle thing is wrong, right? The 60 minutes is actually the hour that we're talking about. So how would we fix that? Yep. Yes, but so where, how, and what? Yep.
You do S mod 360, then to 60.
So here's one way to do it. So once we've factored out the hours in the first part, that's taking the integer part, which is s divided by 3,600, then what we want left is the remainder. How many seconds less than an hour are left after we do that? So that's s mod 3,600, and that's the thing we can divide by 60, and we'll get a number between 0 and 59. So that does it. But there, 1 hour, 0 minutes, 12 seconds. If I change this to, let's say, 37, 1 hour, 1 minute, 52 seconds, so on. So that seems to work. But that expression now is getting a little bit messy, right? So there's a lot going on this one line of code now. We've created a tuple with 3 elements. We're dividing, we're doing this other thing, and it's getting complicated. So maybe we'd like to break this down a little bit. And so what we need to do is maybe make this function a little bit longer. not try and do everything in one line. I mean, this is fine. It's good enough. It's understandable to us, but barely. Let's try and break it up a little bit. So let's first figure out the number of hours. That we know. That's the number of seconds divided by 3600. Now, we want to figure out what's left. So let's say, yes. After that, the number of seconds we're interested in is mod 3600. How many seconds are left after we remove all the seconds that make up those hours? Now we're good to go. We can compute the number of minutes. And then finally, we can compute the number of seconds. And now what do we do? Yep. Yeah.
I have a question.
Yes?
For the hours and the minutes, for what I'm going to put space in between the slash. Wow.
Yes. So it makes no difference at all. You just you do whatever is readable. So it makes no difference in terms of the Python interpreter, the machine. But if you go and read up a little bit on Python and the people that use it, they're quite fussy about issues of style. And so to them, they'll have a specific way that they would like you to do this. And if you're working on a specific project where you want people to accept your code into the project, you'll follow their guidelines. I'm writing code sort of on the fly here, not being too careful about it. But so maybe we'll check to see if that works. So that seems to work. So that's the long version of that function. And sort of the last thing I want to show you today has to do with style. And that's, well, something we've talked about is commenting. All right, so here's this work that we've been saving up today. We've computed the area of a circle, an area of a rectangle, area of a triangle. Something you should do with your functions is describe what it is that they do. And if they're simple, short functions, the way you do that in Python is with what's called a docstring, comes right after the function name. And maybe don't say compute, maybe say return. Okay? So it's nice to have one of these for any of your functions that you expect people to use, because it tells them what the function does. Now there's no ambiguity. They don't have to read the code. They can just read this thing. The area of a rectangle with width W and height H. And so on for these other guys. So here's two things for you. Well, I'll leave you with this. So we've seen from future import division, which gives you this new way of doing division. If you look at the Python documentation, you'll realize there's this thing called the math library. And it has a bunch of functions and things defined for you. And one of those things that's defined actually is pi. And another one of those things that's defined is the square root function. And there's a whole bunch of them, so you can just Google Python math. And so from math, if you want to use any of these things, there's this ceiling, signs, absolute values, factorial, floor, mod for floating points, all kinds of these things. You just use this syntax that says, I want to use this square root function, so from math, import this square root function. Yep.
So do you not have to put double underscores to input things from math?
No, math is a normal standard library, so it's not special at all, so there's no underscores around it. This future thing is something really special. It's not even really a library, so it's those double underscores are to just illustrate that it's something really weird. Yes?
Is there any ways to do like a import like a full library in? Like Java, you can just write import
Just like
library
that.
with a star.
Just like that, import math. But now be careful. So that doesn't import everything. So for example, one of the things in math is log, but it's not working now. So that says import it, but actually you have to specify now where you want that function to be used. So when you say import something from, or from something import this name, it means really import it into the current namespace so that I can use it without saying that it comes from math or that it comes from any other place. Yep.
So back in the note in the text editor, when you put the triple quotation marks,
Yep.
is that that's just another way of commenting like that?
That's just another way of commenting. It actually defines a string, but you're not doing anything with the string, so it just reads right past it. What's that? There's a reason to do it because there's tools for generating documentation for Python code that look for those strings, and then they'll make nice HTML pages that describe what every function does based on those strings. Okay. All right, so that's all for today. Please go have a look at the assignment.